Okay, first possible combination for changes in entropy and enthalpy. If you have them both favorable, you're releasing energy, an exothermic reaction in which things become more chaotic. Consider something like burning coal. Solid carbon plus gaseous oxygen gives you gaseous carbon dioxide and 566.0 kilojoules of energy. So if I look in the green here, I'd say, well, on the left-hand side of the equation, I had solid and gas, and on the right-hand side, the product side, I have gas only. I could consider that a net increase in chaos because I've lost any of the order I had with regard to my solid. Nothing but disorder over here. I had a little bit of order, so I must have gained chaos. The exothermic term in the red, that's pretty simple to find out. I've got a negative delta H because the energy's on the right-hand side of the equation. So I've got a positive delta H, a positive delta S in green here. I'm increasing my chaos. And a negative delta H, I'm releasing energy. They're both favorable. So Gibbs said, okay, delta H minus T delta S, that'll tell me if something is spontaneous or not. Girls have true sensitivity, guys have no true sensitivity. So I don't have to put in numbers, but I can put in the sign. The magnitude we'll take into consideration. Delta H was a negative number minus, these are multiplied together, so T times delta S. Well, temperature we said was always going to be a positive term. Kelvins are always positive. And in this case, delta S was positive. So I've got a negative number minus a positive times a positive. That's a negative minus a positive. For example, I'll just use numbers between 1 and 10. Negative 2 minus, I don't know, positive 5. That gives me negative 7. Negative got more negative. You're never going to have this negative go in the opposite direction. It's always going to continue to go further below zero. It's always going to be a negative delta G. So that means when both changes in enthalpy and entropy are favorable, delta G is always negative. The reaction is always spontaneous. If both conditions are favorable, you always have a spontaneous reaction. In which case, both a negative delta H and a positive delta S would be considered driving forces for that equation. Okay? Next video, please.